Hello, good evening. So I'm Guy, and it's an honor to be here and opening this meetup tonight with the first talk of the night. So big thank you to the organizers and to you all here. So I assume that most of us here today, and also the people following online, are software developers, right? Or not all of them, but most of us are. And I will also assume that we have software developers at different stages in the career where the subject of authentication authorization may or may not be an area of expertise yet, right? Anyway, so soon I will be rambling and speaking all sorts of nonsense here in a way that some of you may think, what the hell is he talking about, right? So why don't we agree on the things that we'll be covering as part of this talk, shall we? As software developers, we develop pieces of software, right? Either for specific or some general purpose software applications or for some software engineering process, right? And at some point in the software process, we usually feel the need for some authorization. And together with authorization, something else, which is slightly different, which is authentication. Usually comes together, but those are two different things, right? I'll be shortening those two things, authentication and authorization, just as all for the moment, right? And I will be postulating here the idea of external authorization as an option or as a way to add authorization and authentication to our software applications that opposes to the more traditional and intuitive way of adding those things that's part of our code base, embedded into the code of our applications. And hopefully I'll be able to convince you that there are very good reasons to do so, right? And especially nowadays when we have new tools that kind of give us a new momentum to think on external authorization compared to any other moment in time, right? And therefore allow us to enjoy the benefits of it from the most obvious ones, like separation of concerns, better flexibility, maintainability, to something that I consider to be probably the most important one, which is the opportunity to reduce the amount of work and most of all the amount of responsibility that usually is put on the shoulders of the developers due to the way that we traditionally implement authentication authorization. Okay. All right. So, well, this is a very quick summary of the things that we'll be covering today. So, if you only had 5 minutes, you're done. Okay? The rest of the talk is just going to the details of this, right? I will not be running any demo as part of this talk, so sorry to disappoint the ones that were expecting that. We will have other demos tonight, but that's part of the different talks, okay? All right, so there we go. So as I was saying, as software developers, we develop software applications, which I will be describing or rephrasing here as functions, right? So this is the most basic software implementation that we can think of. This is what we learned to do when we first got into coding. And if you fast forward to now, this is still what we do, right? So we code some programmatic routines that receive some input and in a way process or parse or transform that input and generate some output, right? So this is the simplest definition that I can think of a software application, right? And so basically that is what I mean by application. I mean functions, right? So that is what we do. Functions that receive inputs, execute some routine and generate some outputs, right? And that is true for the very basic functions that we learned, I don't know, back in the university or maybe in some bootcamp that we did. Maybe functions like to add two numbers together, but it's also valid for the most complex ones, like for business applications and for everything, right? Usually those are functions, they operate on some data resources that we traditionally store in some data storages, right? When we run those software applications, those programs and functions in runtimes that we call servers, we call those programs services, right? And even the definition of a server is kind of a bit fuzzy nowadays, or maybe I should say cloudy nowadays, right? But basically, I refer to those runtimes that implement interfaces that expose ports and provide us connectivity so we can receive requests from a network, right? And those servers, they implement listeners and handlers to parse those requests into the inputs for functions here, right? And because those inputs can come pretty much from anywhere from those networks, we have to ask the question of who is sending the request, right? So one way to solve that problem would be we can just ask the requester to include some identification in it, right? To concatenate some identification, such as, oh, this is what I want, right? That input, by the way, could be anything. Could be a query, right? That's something that can be phrased as a question, and therefore the routine will try to answer the question. It can be a task, like to mutate, to transform that data resource, right? So maybe the requester can say, hey, I want you to query some data, and my name is John, right? Obviously, this is not good enough, right? So anyone could just replace that name and claim to be somebody else, right? So what we usually do, we combine that with some kind of secret, which is known by the requester and can be verified at the side of the service, right, at the other side. So you know that those claims of identity are authentic, right? And this is why we call this authentication, right? So this is the process of verifying that claims of identity are authentic. So you know that in this example, username is a claim of identity. This is my username, right? And because you can verify, validate that secret, it's only known in those two ends of the communication, you can trust that claim of identity, right? Well, you can find, sorry if it's too small, but anyway, it's not, the details are not really important here, but there are several different ways to do that process right? So username and password is just a very basic form of implementing authentication. If you're not an expert, you can Google and you find all information you need on best practices to generate, to issue, to store, to share those secrets that allow you to verify those claims of identity, as well as other standards and other protocols to implement some way of authentication, right? Maybe username and password are more suitable for real people, right, that you are authenticating, whose identity you are authenticating, whereas for machines, there are other ways like API keys, but they are pretty much the same, right? As well as some other more advanced, sophisticated protocols and standards, such as things that we will be covering here tonight, like JSON Web Tokens, or WAL, OpenID Connect, and others, right? But usually, let's keep it simple here. Usually, the way it goes in a username and password kind of example is we implement some table, right, where we can store the users that you know. And what you do is, before going to the part of your function that actually executes something, right, the core implementation of your function, what you do is you query that table to check if that user exists, while at the same time that secret matches, Right? This is a very basic example of things that we do. And you implement some conditional that would say, hey, if the user exists, we continue, we move on. Otherwise, we throw or raise an error saying, hey, not authentication failed, right? So I do not know you. I cannot verify your claims of identity. Okay. Well, in reality, programs and applications are not composed of only one function, but usually multiple functions that make sense to be grouped together, right? Maybe because they represent different operations over the same kind of resource. For example, maybe here it's an operation to read the resource, another one to update, to modify the resource, maybe another one to delete the resource, right? So it makes sense to group them together as part of the same program, but they do slightly different things, right? And because they do different things, one thing is knowing that the user is claims of identity are authentic. So in a way that you recognize that user. Another thing is whether the user can use that particular operation. So another question that we often ask ourselves is, can user S perform operation Y on resource Z? And this is what we call authorization, right? Again, there are multiple different models to implement authorization. From basic things, again, such as the so-called access control list. So there are tables where you have like a user and related to each user, all the operations and resources that user has access to, or the other way around, one resource and all the users that have access to that resource, right? As well as other models as well. So quite popular ones like models of authorization based on rows, right? As well as other ones that are becoming more and more popular every day, right? Like attribute-based access control, also sometimes referred to as policies, right? And other less known ones like authorization based on time, based on network context, and so on, right? But in general, again, they all go more or less like so. You have another table or set of other tables that represent those permissions, who can perform what, who can do what, right? And you query those tables now that you know that the claims of identity are authentic, so you know the user, right? So you can check if that user or group or however you identify the request is associated with the proper permission to execute that particular function, right? So at this point, you start adding to your code multiple if conditions that precede the actual core functionality that you implemented, only so you can authenticate and authorize before actually performing what the function is supposed to do, right? Well, of course, we are good citizens and good developers, so we learned that this is no good, where you have multiple ifs and multiple repetition here. So we start refactoring things, right? So we start doing some don't repeat yourself. And maybe one thing that we can do, I don't know if you can see this here, but hopefully in the shared one is we have better definition. But one thing you can do is you can avoid those repetition by extracting those common implementations of what is the authentication, what is the authorization function, and in the actual core functionalities of your application, you just invoke those, right? And this is an example of a separation of what is known as the decision point in the authentication authorization processes and what is the enforcement point. So one thing is the function that decides whether the claims are authentic or not, and also whether access shall be granted or not. Another thing is the actual if that we still have here that enforces that decision, right? There are multiple other design patterns that allows to hide even more the fact that there are some ifs here, right? Some patterns such as middlewares or even some fancy stuff nowadays that you can do, like just add some annotations to your function that transform that into some magic that implement for you the exact same functionality, right? We can go one step further and with this very example and not only extract authenticate and authorize as two separate functions, but because we're talking about a service, right? Usually this is how it looks like. We have a handle function that handles the request. Because this is kind of a common spot, an entry point to your service, this is where you usually invoke those authenticate and authorize functions. And then you have a router that actually redirects to the exact function that implements the functionality that the user is actually interested in, right? This is good. This is already good, because at least we managed to separate all from the rest, right? And we are back to the state where we originally were when we first presented those functions, where the functions is nothing but the routine and returning the output. Okay, so this is good, right? However, if you ever heard the word microservices, you know that reality is way more complex than that, right? So something that within the scope of one single program looks like this, a clear separation between auth and code, right? When you extrapolate that to a more complex system, becomes more something like this, where you have multiple applications. Each one of those applications, they may have all either implemented as a separate concern within this part of the code base, or something more mixed in, such as in the other one. But as you can see, again, we are back to having all scattered all over and all across your system, right? And different ways and different protocols, different standards to implement those, right? I want you to take a look at this just for a second and think on someone coming and asking the following question to you. How do you ensure that all users only with the right level of privilege can access the functionality of your system, right? Well, if you're lucky, you were the one who implemented all that. So, and you have a flawless memory, right? So you know exactly where to go to answer that question, right? If you're not that lucky, you inherited some legacy code, right? And you did not implement everything. But don't get me wrong, right? Either way, you will be the one asked to answer that question, right? So you will be requested to gather all the evidences to prove that whatever answer you come up with are true, right? Guess what? If you work at bank, or I don't know, maybe in the payment processing industry, right? This kind of question you will be asked at least twice a year as part of a formal process of auditing, right? Well, this is where external authorization comes in, right? So the idea of external authorization is, and this is described in a very abstract way, but try to imagine if you could extract all that auth or part of that auth to another layer, right? Or all those definitions could be grouped together, so you can clearly separate and define this that I'm calling here as the external authorization layer, right? And remove that from your code. That external authorization layer can be multiple things, right? It can be a centralized authorization server that, for example, handles all the identities and issuing the identities, management of the identities. So it's an identity provider, an IDP. Functionalities that we are more and more getting used to nowadays, such as the SSO services, the single sign-on services, right? But also a place where you store your policy definitions, right? And by policy, I mean the rules, right? Or authorization and authentication. Some services that are which purpose are serving as information points for the authorization services. So that is what the PIP stands for, so policy information point. And also the policy decisions points that I exemplified as part of our code a couple of slides ago, right? Or anything that falls into this, that nowadays it's called the identity and access management systems, right? So this is what I mean by external auth, a layer where you can put everything that related to all separated and extracted from your code, right? Or the part that it's actually enforced. But one traditional and also intuitive way to externalize auth is by externalizing only the policy decision point, meaning a service that you can invoke just to decide, shall access be granted here, yes or no, but the actual enforcement of that decision still lives inside of the code, right? So this is a very common, very usual pattern. It's very common through libraries, for example, for application authorization, where you import the library, but the library still requests you to implement an if condition before the function that says that, hey, invoke the service. But this is already okay, because it at least allows us to turn those implementations of those authenticated and authorized functions into proper abstractions that actually become adapters, right? That invoke the centralized service. So it is also it's in the right direction, I would say, right? And this is a way to move towards external authorization, right? A traditional way. Another way that makes the external authorization layer even more transparent to your applications is the pattern usually implemented by the so-called API gateways and sidecar proxies or proxies in general, which is a way where you wrap your application into some type of vessel, some type of shield that protects your application in a way that no traffic will flow to your application unless it's first verified or authenticated and authorized, right? This is another way. So you still have the centralized PDP, but you have some kind of layer covering your application, which is doesn't know anything about authentication authorization, but all the traffic passes through this layer. So that layer makes sure that no traffic will flow if not properly authenticated authorized, right? And then finally, we have something that I consider to be the evolution of the previous one, which is something that is becoming more and more viable with the current tools that we have available nowadays, right? Which is a situation where you have a control plane that instead of having those distributed points that are responsible for enforcement always calling on centralized server, you have the inverted topology here. So you have from the control plane, your policy definitions being pushed to those distributed in more satellite services. So you combine both things closer to your application, yet not inside of the application. So you can still manage all the policy definitions, all the authorization aspect, authentication authorization rules at the layer of the control plane, but that pushes to the more distributed network, so you don't run into the obvious issue of the bottleneck of always going to that centralized service, right? And with that, we can start considering once again enjoying benefits of external authorization, such as things that already became obvious from the conversation, and like the separation of concerns that I mentioned, right? So you have all in one place and the actual core functionality of functions in another one, right? You have decoupling, not only from the code decoupling, so you don't run into the risk of writing an if condition or instantiating a class, for example, for the all functionality inside of your code. So you can get free of that risk of coupling of code, but also decoupling of scalability. Because now you actually have two separate layers. So you can scale each layer accordingly, right? So you can scale the layer of the implementation of your functions and also the layer of authentication authorization. The benefits of don't repeat yourself, not only inside of the same application, the same code base, but across multiple applications, right? You can spot same policies slightly implemented slightly differently in different parts of your ecosystem of applications here, and maybe join them together, right? Do some standardization. Of course, we want to do that in a way that is flexible enough, right? Because no one wants to move to a scenario like this, but get limited only with the options that some particular vendor gives us with, right? So we want for that layer to be flexible, right? And amongst all the benefits as well, for example, since you had some centralized storage where you define your policies, right, and those are being pushed to the network, that also and makes possible for better governance, right? So especially in corporate environments where you have to run those through auditing processes and you have to comply with company level policies, it's good that you have a common source of truth for all the parts where you're actually enforcing those, right? Of course, the idea is that you pick solutions that makes easier for us to implement the best practices, right? And as part of the best practices, I will include protocols. I think there will be talks here today about protocols as well and standards, right? We don't want to go into the risk of reinventing auth, right? It's always good if we stick with the protocols, which are normally stressed and discussed, right? So they are scrutinized regularly. So it's always the safer way of implementing auth. And by the way, this is actually one of the best practices, right? So, and we believe that the time for this is now. Nothing that I've said here so far is entirely new, right? External authorization exists since many years. What's really new is the tools that we now have available that created us at a new momentum for external authorization, right? Nowadays, we have things like Kubernetes, which is not only a good platform for running your containerized applications, but something that you may or may not know is that Kubernetes also offers authentication and authorization services, right, for applications to just use. So Kubernetes authentication and Kubernetes RBAC are not only for configurability of the Kubernetes clusters, they are offered as services that can be that the applications can leverage from, right? Tools like Envoy. Envoy, I don't know if you know, but it's a general purpose proxy that's becoming more and more popular. It comes with not only provides some good connectivity, but also lots of extension options to add functionality on all the traffic that's either incoming or outgoing traffic from the external of your applications, right? And it gives also transparency. So it's a terrific piece of software that I totally recommend checking out. Istio, which is a service mesh management system that I'm putting here because I consider it to be kind of the measure or the synthesis of both things. So you can think of Istio as not only for microservices, but in general, Envoy on Kubernetes, right? It's or Kubernetes native Envoy. So it's a fine piece of software also that makes our lives a lot easier. Right? It's quite ubiquitous, right? So when you have a Kubernetes cluster running Istio, you can have that control plane that I mentioned easily injected in all your workloads. And I also like to mention one last thing, which is Policy Engine, which is also very, very nice. Open Policy Agent or OPA, which gives us all the expression power and all that flexibility that I mentioned to implement whatever kind of auto model of auth that we want, right? Because we have these tools nowadays that we didn't have in the past, we can think of leveraging external authorization in a way that we never did. And that is my message for this first talk. I don't know how long we took. So
I think we are pretty tight, but if you have one or two questions here or remote, we have some time.
If not, it's okay.
We'll give it for the second presentation.
Thank you.
Thank you too.
I have a question.
Sure.
There was a slide where you showed where you started scaring us with the many different kind of services and having authentication all over the place, right?
Right.
And I was wondering, is there a certain scale that you think it starts making sense to externalize your authorization, or is it with your experience now? Is it like a startup starts building this new API? Should we just be focusing on some space? Should we be focusing on the kind of just building the core functionality, the functions, and leaving authentication and authorization.
I'm afraid I don't have a right answer to that question. I don't think there is an actual number, right? If there is, I would say if it's plural, then it's already worth considering, right? Because if you only have one single service and you manage to isolate things, like let's say it's a huge monolith, right? But still you manage to separate all from the rest. Maybe it's fine. But let's remember that it's not only about maintainability. It's also about being able to delegate part of the responsibility to someone else. If it's code, that means it's under your responsibility. Whereas if you can represent that in some other way, you can start sharing that responsibility with more parts inside of the company. For example, a security officer. So let's say you can separate the policy definition from the actual bits and pieces of software that implement, execute that, right? Maybe it's something that is a policy defined at the company level, right? Why do you have to be the only one who knows how to read that, right? To understand that. Or maybe there are proper languages that allow other people inside of the organization to represent and to maintain that.
That's a good point, thanks. Because you just brought into my mind like past experience, even with the monolith, and kind of just changing, upgrading it or modernizing it. One of the biggest stumbling blocks was the kind of homegrown authentication and authorization.
Right. Yeah. Thanks. One question that usually pops up here, sorry, so I'm taking too long, I'll be very quick, is because I also want to be fair about the flip side of it, right? Because if you have everything baked inside of your code, there are some challenges, right? But at least on the other hand, you have the benefit that it's supposedly efficient, right? Because you can compile that, for example, and you can execute that as part of the same application. Whereas here we're clearly talking about separate processes, right? So at least some communication between processes. And something that used to be in the past at the scale or the magnitude of nanoseconds, it become milliseconds, right? Because there is some communication, right? Well, that is a very fair point. So one thing that we want to look for whenever we look for those solutions are functionalities such as caching, right? So we wouldn't consider such distributed systems unless they could cache decisions and things, so make things speed up and fast. Also, the kind of protocol communication. Nowadays, we have things like gRPC that allow the communication between those two separate services to happen a lot more efficient compared to, I don't know, other protocols from the past, right? So that's why I believe that it's a good moment to think about it.
Also, something that happens is that when you implement something internally, let's say, you want to do it fast most of the times, you don't go with the protocols. So it is a huge pain when you want to extract it to something protocol-based or product-based or whatever.
Sure.
So you have to migrate also to the protocol and then also to support the external line.
Right. I couldn't agree more. Yeah. So yeah, that is absolutely correct, right? So if you implement yourself, also the burden of following the protocols, if you are following any, right, is on you. Whereas if you can rely on some off-the-shelf solution that is compliant with the protocols, I mean, that is also less responsibility on you as well. Totally agree. Right?
So one more question.
Sure.
I haven't never implemented something with a sidecar or close, as you said. So in those cases, you configure everything on the wrapper of the sidecar, let's say, and then the service is completely in mode of authentication, authorization.
Usually that's how it goes. Yes.
So it's like YAML files that you define somehow this endpoint has this capabilities.
In a Kubernetes world, yes, it's usually YAML files. That is how you represent the rules, right? It doesn't have to be. There are different solutions out there that work with different languages. What really matters is usually that pattern that I showed here goes more or less the following. You configure that external layer, that proxy or that API gateway, right, with the rules. And your application, as you said, is ignorant about the fact that there is some authentication authorization going on. In fact, what your application does, it starts listening only at the local host requests and rejects all the incoming traffic. That guarantees that only that external proxy can communicate with the application.
So it's like a two-step procedure, but you implement something and then you configure the privileges for others.
Yes. Yes. Hopefully, I'll be able to demonstrate that in practice with my next talk
Great.
and well, one of the tools.
Thank you.
Thank you.